Hello everyone, welcome to the series of videos on naming organic molecules using the IUPAC system, IUPAC. I don't have my normal setup. Apologize if the audio and video quality is not quite as good as normal. In this video we are going to we're going to rather learn to name alcohols and carboxylic acids. So you see here the set of functional group flashcards that we made already. So first of all, starting with the alcohol, we have the OH attached to some number of carbon atoms. So the class is called alcohol. Specifically, this functional group is called hydroxyl. Make sure you know those things and make the distinction. As with all functional groups, we want to start by, naming in general, we want to start by finding the longest chain of carbon atoms, and then we want to say exactly where this functional group is, and with most functional groups, they're named with a suffix. So in this case, the example you have here, 1, 2, 3, 4, 5. The longest number of carbon atoms that we can get is 5. We want to give the functional group the lowest possible number that we can. So either way we count, whether we count from this side or we count from this side, that is attached to carbon 3. So since it's 5 carbons, it's pentan, and then on carbon 3, and then all. So pentan-3-ol is how you name that one. I'm going to go through 4 more examples for you. I'm going to use the ChemSketch program to help you look at these. So here we have another example here. It's an alcohol. We've got this OH group sitting here connected to some number of carbon atoms. The difference between, this one is going to be what we call a secondary alcohol, but we want to start by finding the longest possible chain of carbon atoms. 1, 2, 3, 4, 5, 6. We are going to number it in that direction because if I number it from the other way, this is carbon 5. We're going to get the lowest possible number that we can. And so this is on carbon 2. So this is hexane 2-ol. And one nice thing about ChemSketch is if we use the select tool, and there's a option up here to name the structure, but the keyboard shortcut is Control-Shift-I. And so one nice thing about this is we can use this to actually kind of check our answers, or just mess around and play around and check answers and stuff like that. Okay, so another example here. Longest chain of carbon atoms: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So no matter how we count it, there's only 6 carbons that we can get to. So hexane is going to be the base name. Again, we're going to state that the hydroxyl here is on carbon 2. But now we've got this methyl group. So I should say that functional groups are going to get numbering priority over methyl groups and ethyl groups and other carbon side chains. So rather than numbering it this way, where the methyl is going to be on carbon 2, we're going to number it this way because this gets numbering priority. And there's a whole hierarchy of numbering priorities. I don't think we need to get into too much, but just know that any functional group really is going to get numbering priority over a side chain. So we need to tell where the methyl group is, and we need to tell where the hydroxyl group is. So 1, 2, 3, 4, 5, 6. The methyl group is on 5, so that's going to get named as a prefix. So if we circle it and we do Control-Shift-I, this is going to be 5-methyl-hexane 2-ol. 5-methyl-hexane 2-ol. Okay. Another example here. This guy right here. Now this is just 2 carbons, so that's ethane, and there is a carbon. There is the hydroxyl group here on carbon 1, but it's kind of redundant to say ethane 1-ol, and the reason for that is because whether the hydroxyl group is here or here, it would still be carbon 1, and so it is a little bit redundant to say ethane 1-ol. And so in those cases, it's generally okay to leave the number off, and as this thing does right here, so this is just good old ethanol. Let's look at this last one, this last example, at least for the alcohols. Now, one thing we notice about this is it has 2 hydroxyl groups. It's a propane type situation because there's 3 carbons here. They're both on carbon 2. So remember, whenever we have 2 of the same thing, we're going to use the di prefix. So this is going to become diol. And then again, we have to say where both of these are located. So This is going to be propane. Now it's a little weird when that di comes in. They notice the E comes back on the end of the name. Propane 2,2-diol. And that is to distinguish. The reason why we need to say 2,2 is that is going to distinguish it from something where the hydroxyls were on separate carbon atoms. Like for example, one thing that's nice about ChemSketch is we can pretty easily make quick sketches. So, the reason why you need that 2,2 again is to say that both of the hydroxyl groups are on consecutive carbons. In this case, they're on consecutive carbons, but in this case, they're on the same carbon. So these two things have different names. This is going to be propane 2,2, propane 1,2 rather, diol. So different names, and this is true of any type of functional group. If there's more than one of them, we need to give a number to say where both the functional groups are. So that is alcohols. Let us look at carboxylic acids. So I'm not going to name these things in the order that they are here in the flashcards. Let's jump down to the carboxylic acid one. Okay, so carboxylic acids characterized by what we call a carbonyl, a carbon double bonded to an oxygen, and a hydroxyl. Both of them connected to the same carbon atom, and then there's some number of carbon atoms over here. Carboxylic acids, by definition, are always going to be at the end of a chain, so they don't need a number. Because if they weren't at the very end of a chain, they wouldn't be a carboxylic acid. And they get a suffix, an oic acid suffix. They're probably one of the easier functional groups to name just because they are always at the end and you don't need to worry about that numbering system. You still need to count the number of carbon atoms, and there are two. Notice that I'm counting the carbon that's in the carbonyl here. So there's 2 carbon atoms, so this is ethanoic acid. That's another name for vinegar. The more old school name for that is acetic acid, and in some cases, like with ChemSketch would probably call this acetic acid, or you'd hear it called acetic acid a lot, but the official IUPAC name is ethanoic acid, and IB always uses the official IUPAC names. So a couple examples here of different carboxylic acids. So the longest number of carbon atoms is 3. Again, I am counting that one. So the word for 3 is prop. So this is going to be propanoic acid. And we'll just check ourselves with the naming generator. And yes, indeed, we are correct. Okay, here's another example. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the longest number of carbon atoms we can get. 1, 2, 3, 4, 5. Still, 5 is the longest we could get. Now, we don't need a number for the carboxylic acid, but it still is going to get numbering priority. In other words, this is going to be carbon 1, and this is going to be carbon 5. So, and that's a methyl group. So if I generate our little naming system here, we see that it is, did I say 5? It is 4. 1, 2, 3, 4. There's only 5 carbons total. 4-methyl pentanoic acid. So pentanoic acid, because it's a 5-carbon long thing with a carboxylic acid on the end, and 4-methyl because this is carbon 1. 1, 2, 3, 4. Okay, one more example here. This is another case where we have 2. Sometimes it's going to sound a little weird, but whenever you have 2 of the same thing, just throw that di in front of it. Again, don't need numbers because this is a carboxylic acid, so it's always on the end of the chain. The total number of carbons includes the carbonyls 1, 2, 3, 4, 5, 6. So this is going to be hexane dioic acid. Notice again the E comes back when we do the di thing, just like with the alcohols, and dioic acid. Okay, so there you have it. Be sure to let me know when you have questions, and we will continue this video series with a couple of their videos. Thanks for watching.